Algebra 2 honors. So here's your Unit 2 review. Okay, so number 1, use the quadratic formula to solve x squared plus 8x plus 2. Okay, well I noticed right away, let me zoom in, focus that a little bit, that if I try to do like, let's say the x, and just try to factor this out, let's say 2 goes up here, 8 goes down here, and again that's 8 times c, or 1 times 2 is 2. I try to find two numbers that multiply to 2 to add up to 8. Obviously nothing's going to work because only number that works is 2 and 1. That's not going to give us 8. So the next thing I'm thinking is let's try completing the square. Quadratic formula, yes, it works for everything. You can set that up, but I always prefer to do complete the square before that. Okay, so first thing I'm going to move this 2 to the right side because remember we need to get the c term. Always you got to move it to the other side of the equal sign. Then we want to complete the square. Now again, completing the square is just half of 8 and then square it. So half of 8 is 4. 4 squared is 16. And then we need to add that to both sides of the equal sign in order to balance the equation. Okay, now what I can do is factor this. This becomes x plus 4. And if that's plus 8, that'll be plus 4. If that's minus 8, that'll be minus 4. Then we add the other side, 14. And now we can just square root. Square root both sides. Okay, x plus 4 equals, okay, don't forget, plus or minus 14, square root of 14. Okay, then subtract 4 from both sides. You get negative 4 plus or minus square root of 14. Now, what I want you guys to do is I want this to be in decimal form to the nearest hundredth. So go ahead and get out your calculator. We'll do negative 4 plus the square root of 14. Okay, so we're going to do first x is equal to negative 0.26, round that up. Okay, and then let's go back up, change that to minus this time. All right, so now then we'll get negative 7.74. Okay, so make sure you guys convert those to decimal, as long as it's not imaginary. Okay, all right, so now what is the product of 7 minus 2i and 7 plus 2i. Again, product means multiply. So we're going to multiply these two. And I'm going to go ahead and use the box. If you guys don't know what I mean, this is basically what this is saying. The product means this. Okay, so I'm going to use the box. I'm going to put 7 here and negative 2i, and then 7 here and positive 2i. So 7 times 7, 49. 7 times 2i, 14i. Negative 2 times 7, negative 2i times 7 is negative 14i. Sorry if it's a little small, that's a 14 there. Okay, then negative 2 times 2 is negative 4. I times I is I squared. Okay, but remember I squared is equal to negative 1. So really, this negative 4 times, it's negative 4 times negative 1, which becomes 4. Okay, so there's a 4 there. So now the nice thing about this is I can add up the terms diagonally. Remember, you're going to combine the like terms, so 49 plus 4, that's 53. And notice I'm doing the real number first. Remember, you got to do real number first, then the imaginary part, and then negative 14i and positive 14i. Well, those are just going to cancel, so then my answer is just 53. Okay, but if that doesn't cancel, remember you got to put the imaginary second. Now, what I need to figure out for this, I need to figure out what the quadratic equation is for this graph. So in order to do that, let's find the important pieces of information that we already know just looking at it. Well, there's no x-intercept, so I can't use that. But I do know the vertex, and that looks like it's 1 and 1, 2, 3, 1 and positive 3. I do know the y-intercept, so 0 and 6. Okay, so let's use that information. So vertex is 1, 3. Y-intercept is 0, 6. Okay, well I know in the vertex form, it would look something like this. I know part of that equation. I know if I put this in parentheses, this would be x minus 1. Okay, and then I'd have plus 3. Okay, so now how do I fill in the rest of the equation? Because I don't know what this number is. That's really the last piece that I need to know. Okay, well I do know the y-intercept. So in other words, if I plug in 0, I should get 6. So I could rewrite this equation as 6 here for y, And then if I plug in 0, I should get 6. So that means I can solve for this missing number. And we'll call this number, remember this is a. Okay, so let's just solve. Okay, so 6 equals a, negative 1, 0 minus negative 1 is just negative 1, then squared, well, that's just 1, plus 3. Okay, so obviously you can see it's not that bad, right? Okay, then just a plus 3, subtract the 3, and a is equal to 3. Okay, so then that final equation looked like this. Is 3 times x minus 1 squared plus 3. Okay? Okay, so now name a function that could have the zeros at 2 and minus 3. More than one answer could be applicable. All right, so let's think about it this way. If I had the factors written out, and I had x here, if a 0 is 2, in other words, x equals 2, and x equals minus 3, remember x is a liar, so this wouldn't be plus 2, this would say minus 2, and if that's negative 3, this would say plus 3. So that's one possibility. Okay, or I could put a number out here. Okay, or kind of any number you want. Okay, so those are possibilities for making this, or you could put a fraction. Okay, so but remember it's got to be a function, right? So we're going to put function notation, f of x equals, okay, whatever you come up with. Okay, so that's the main thing, is we got to do that. So now what we want to do is expand this out. So I'm going to go from here. Sorry, not expand it. I actually want to multiply it out. Okay, so we're going to have f of x equals 3 times, let's see, well, that will be x squared, then that will be plus x, then that will be minus 6. And then I'll distribute the 3. And again, you could just do it without the 3, then stop there. Okay, but I went ahead and did extra and put in the 3. Okay, so plus 3x, then minus 18, and then don't forget the notation. Okay, so that's one possibility. Okay, all right, so then given, zoom out a little bit, given f of x equals x plus 3 minus 8, give a possible equation for g of x, which has been translated. Okay, so we're doing transformations. Okay, so we're starting here. It's been translated 5 units left and 2 units down from this equation and is vertically wider. Okay, so we are starting here. We're going to start here, right? So we're going to start at, you can kind of look at this any way you want, but I'm going to start with the vertex. Because remember, that's the middle of the graph. That's the part that's going to shift around. Okay, so we have negative 3, negative 8. It's going to translate 5 units left, right? So left would be in the more negative direction. So let's say 1, 2, 3. So, and it's like way down here, 1, 2, 3, 5, right? That means it's going to move this way and become more, and that x value is going to become more negative, right? But by 5 units. Okay, so then that means we're going to have negative 5. Sorry, not negative 5. It's going to be negative 8. My bad. Okay, and it's also going to go 2 units down. So from negative 8 going down is again more negative, so minus 10. Okay, but it's also going to change vertically wider. So let's first rewrite this. We're going to do g of x. Remember, we've got to change that. Okay, then in the parentheses, it's no longer going to be 3. It's going to be 8. So plus 8, because remember, x is a liar. And then minus 10 on the outside. But it says vertically wider. Okay, we have to think about this. Vertically wider. So let's think about a rubber band. Pull out a rubber band over here. Vertically wider, right? So let's start with my rubber band like this. Wider means I'm stretching it this way. Okay, stretching it this way. Or I'm squishing it from top to bottom, compressing it, right? Compress, how do we get a vertical compression? Okay, a vertical compression, this number has to be less than 1. Okay, so we could do something like 1/2. Okay, so you have to think about vertically wider. What does that mean? Because the terms that you're familiar with are with compression and stretch. A stretch let's say if you say, this said vertically narrower, right? That means it's stretching this way. Okay, but if it's wider, that means it's compressing this way. Okay, we have to think about it that way. All right, so use a description to write the quadratic function in vertex form. Okay, so this is x squared. Okay, so this one is going to be, so again, vertex form, vertically compressed by a factor of 3/4. Vertically compressed. All right, so first of all, g of x, because it's a new equation. So we have 3/4 on the outside. Remember, vertical goes on the outside, right? Okay, and says reflected across the x-axis. Well, that is, again, a vertical on the outside, so negative there. Then translated 3 units right. Okay, so if we're going to the right is more positive, right? But remember, x is a liar, so this would be minus, oops, sorry, not 4, it should be 3. Minus 3. Okay, then 1 unit up to create g of x. So then that just changes that number outside. Okay, now the next question is the width of a rectangle. Okay, right away I hear width rectangle is 4 inches less than twice the length. So let's draw this out. So if I have a rectangle, it says that the width of the rectangle is 4 inches less than twice the length. Okay, so it's comparing the width to the length. Okay, so the width is 4 inches less than twice the length. So in other words, the width, let's say we call the length x. And actually, you know what? Let's just call it L, just because it's the length. Okay, the width is 4 inches less than twice. So 2 times, and this is L. So 2 times the length, then is and then minus 4 inches gives us the side. Okay. Now it says the area of the rectangle is 390 square inches, and it's asking for the length. So we're trying to find this side. Okay, so well, if we remember, area of a rectangle is base times height. Okay, or you may have heard length times width, same thing, right? Okay, so if I take L times 2L minus 4, because that represents the width, the 2L minus 4 expression, that should give me 390. Okay, so that isn't the expression or equation we can use to solve for that length. So we're looking for L. So let's just solve the equation. So distribute L. So this L times 2L would be 2L squared. Okay, minus 4 times L, which is 4L. Okay, so right now I'm recognizing right away I've got two terms that have a variable. Okay, if you're somebody who's used to seeing x all the time, this is the same thing as 2x squared minus 4x equals 390. It's just we have L instead of x. So I noticed, like, if I had a question like this, one, I can't do the square root method because I have two variables with x. Okay, so that wouldn't work. So I could probably do either complete the square, factor, or quadratic formula. Well, now right away I'm noticing these are pretty large values, so I don't want to factor because factor is just not as easy when you have large values. So I'm either going to complete the square or quadratic formula. I always pick quadratic formula last because that's where you make the most mistakes and it's a lot of steps involved. Okay, so let's do complete the square. Well, first of all, remember that first term next to the squared term, that first number needs to be divided out. You need to get rid of that first. So divide that by 2, we get L squared. So I can divide everything by 2 again. And then this will be 195. Okay, now in order to complete the square, remember we're going to complete the square with the negative 2 on this side. So remember half of negative 2 is negative 1. And then square that same number. Negative 1 squared is plus 1. Okay, then we have to add it to both sides. And I'm liking this one already because I know that that'll give us a perfect square over there. Now let's factor this. Okay, well remember that's negative 2, so this number is just going to be half of that, x minus 1, or x minus 1 times x minus 1 is that same thing factored out, or that same expression factored. Again, we have 196. I could square root this side and square root this side. Let's move it on up. Okay, so now we have x minus 1 equals plus and minus 14, don't forget. Then I'm going to move this 1 over here, so it'll become positive 1 plus or minus 14. Okay, so we're going to have two solutions here. The first one will be 1 plus 14 is 15, and then 1 minus 14 is negative 13. Oh, and I just totally changed everything to x. Some of you guys are like, Mr. Osborne, you just supposed to do L, and then you used x the whole rest of the way through. Okay, so L, 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 L. All right, so the question is, there can only be one length. And I'm looking at this. There's no way we can have a negative length, so we can't have negative 13. So that's the only possible solution, is the length is 15. Okay, but 15 what? Because remember, this is an actual real life problem, so 15 inches. So don't just say 15, but it's 15 inches.